Okay, here we will talk about the singular value decomposition of a matrix. So a singular value decomposition is when you write a given matrix A into the product of three matrices, the matrix U, sigma, and V transpose. Okay? And so, basically, how do you proceed? Basically, what you will do is you will calculate A transpose A and A transpose. Okay? And then you find the eigen values. Just to know it, the eigenvalues of A transpose A and A transpose will be the same. Okay, so you just have to calculate one of them. Okay, basically, once you have your eigenvalues, the matrix sigma is a diagonal matrix. It can have a bunch of 0 rows or 0 columns. Okay, so it can be some diagonal entries. Then you can have zeros on the side or zeros below. Okay, but the non-zero entries are always on the diagonal. Okay, the entries of that matrix are sigma 1 until sigma E. Let's call it E. So, basically, the sigma is given by the square root of the eigenvalue. Okay, so sigma 1 will be the square root of the first eigenvalue, and you have to be careful because the sigmas have to be put in the sigma 1 has to be the biggest square root possible. Okay, so let's say, for example, you have lambda 1 equals 3, lambda 2 equals 5, and lambda 3 equals negative, let's say negative 2. Basically, first of all, you don't, that there is a negative sign, it doesn't matter. You only consider the length, okay? So basically, you will, here in this case, sigma 1, so the first, the sigmas are called singular values, okay? They are just the square root of the eigenvalues. So the biggest square root will be 5, then square root of 3, then square root of 2, okay? You only consider you don't consider the sign, okay? So for example, if instead of, if you had instead of minus 2 you had minus 4, the square root of 3 will be at the bottom, and here you would have square root of 4, okay, which is 2. Okay. Okay, so that will be your matrix sigma. Then, basically, once you found your eigenvalues, the matrix V will contain the eigenvectors. So it's called V1, V2. Don't know how many there are for them. Let's call it Vn. Basically, there it has the orthonormal, that it contains the eigenvectors when you find the eigenvectors of A transpose A. Okay, once you found them, you have to make them unit vectors, so of length 1, and yeah, and V and U are both orthogonal. Okay, and to find U, U contains, so the vectors U1 to don't know how many UM, don't know. And basically here it will be the eigenvectors of the matrix A transpose, okay, with the eigenvalues that you get at the beginning, which are the same for A transpose A and A transpose, okay. So you proceed that way, and let's say you have already found the vectors for V, okay. Let's say you already know there are 3 columns, and there will be V1, V2, and V3. Okay. There is you still need to find the vectors for U. Okay. There you can use some formula. Basically, the vector U1 it will be it will be 1 over sigma 1 times the matrix A times the vector V1. Okay. U2 will be 1 over sigma 2 times A times V2. Okay. And for V it is similar. If you know the vectors for U but not the vectors for V, let's say vector V1, it will be given by 1 over sigma 1 times A transpose. Be careful, A transpose times U1. V2 will be given by 1 over sigma 2 times A transpose times U2. And V3 will be given in the same manner, and U3 will here be given as before. Okay? And if it happens that you have one single value on the diagonal that is 0, you can't use that formula because you divide by sigma here and here. Okay? So what you do in this case is you can take whatever vector you want. Let's say you still need to find U3. Say you have 3 vectors. To find it, you can take whatever vector you want. You just need to make sure that U3 is orthogonal to U2 and it is also orthogonal to U1. Okay? So it needs to be orthogonal to every other vector, and it needs to be of length 1. Length equals 1. So for example, you could use Gram-Schmidt. You take whatever vector you want. You use Gram-Schmidt to make a vector that is orthogonal to the others. If it happens that if you are in 3 dimensions, okay, x1. If you are in 3 dimensions, what you can do is let's call it y1, y2, y3. You can just use the cross product. Okay. If it happens that you're in 3 dimensions, otherwise you use Gram-Schmidt or some other method to get an orthonormal vector. So it has to be of length 1. Here, if you use the cross product, if U1 and U2 are already unit vectors, you will get unit vectors for U3. Otherwise, you need to divide by its length to get the unit vector. Okay. And so you proceed that way to find A equals U sigma V transpose. So for V transpose, you need to transpose it once you find V. Okay. So just to recapitulate, you need to find the eigenvalues of A transpose A or A transpose. These are the same eigenvalues. Okay? Then you find you can find the eigenvectors, the orthonormal eigenvectors. So of x1 for V, which will you apply the eigenvalues to A transpose A, and for U you apply the eigenvalues to A transpose. Okay, you don't, as said, you don't need to find the eigenvector. You don't need to calculate A transpose A and A transpose. You don't need to calculate both. You can use that formula before. That once you found the vectors of V, if you have found V, let's say you know V1, you can use the formula that U1 will be 1 over sigma 1 times A times V1, and so on. And let's say you already found U1, then V1 will be 1 over sigma 1 times A transpose times U1. This is U. Okay? And if it happens that your single value is 0, so you can't divide by 0, then you take whatever vector you want. It just needs to be orthogonal to the other vectors of V or the other vectors of U. Okay, depends for what vectors you are looking for. Okay, and so you can use Gram-Schmidt, or if you are in 3 dimensions, you can use the cross product, and then take the length, the unit vector. And so yeah, you can find your singular value decomposition. And yeah, that's all. Thanks for watching.